In this video, I'm going to explore how we can use MATLAB to evaluate definite and indefinite integrals. So what I've done here is I've entered some text of the integrals that I will be using for demonstration. So this is a live script, so I've entered in these integrals here. So these are the ones that I will be evaluating. The next step there is now to enter the code to evaluate these given integrals. So what I'll do is I'll come here, click here, press the return key, and then on the live editor, I click on code. So for the code that we want to use, I'll start by creating symbolic variables. So I type in syms. So for the symbolic variables, if you look at the integrals that we have here, we have an x, an x, an x, but here we have a y and a t, and here we have an x. So for the symbolic variables that we need x, y, and t. I press the return key. I now go on and look at the first integral here, the integral of x with respect to x. So for that integral, I enter the expression that I want to integrate. So I'll call it E1. My first expression is equals to x. Press the return key. I can just run so that we can see that the E1 here saying is x. We now go on and integrate this E1. So I want to call the result I1 is equals to, we use the command int, open parenthesis, and we are saying we are integrating E1. By default, this command here, int, it evaluates the integral with respect to the default variable. The default variable is x, or a variable which is closer to x on the alphabet. So in this case, we are just integrating with respect to x, so there's no need of specifying there that I'm integrating with respect to x. So I can then go on and run here, and it gives us the I1, the output there is x squared divided by 2. I now go on to the second one, this one here. We are now integrating the square root of x minus 1. So I'll click here, press the return key. So I'll call the second one E2. E2 is equals to, for the square root, the MATLAB command is sqrt. Then open parenthesis, we are saying the square root of x minus 1. So for the square root of x minus 1, let me just run there, see if so we have our E2. The second expression is square root of x minus 1. Then we go on and integrate this expression that we've just entered. So the command there, I'll call it I2. So we have I2 is equals to int, open parenthesis, we are integrating expression 2. So again, here we are integrating with respect to x. So there's no need for me to specify here, because MATLAB will just pick up it's integrating there with respect to x. So I can go on and run. So the integral of the expression E2 is 2 multiplied by x minus 1 to the power 3 over 2 divided by 3. I now go on to the next integral. We are now looking at this one here, x cosine x with respect to x. So I can come here, press the return key, click here, say I'm now entering the code. So we now have this expression x cosine x. So I'll call that expression E3 is equals to x, then multiplied by cosine, open parenthesis, x. We should not leave this multiplication sign, otherwise it will give some errors there. So I can just run. So we have our expression number 3 is x cosine x, then go on and integrate it. So we'd have to call it I3 is equals to int, we are integrating E3. So for the integral of E3, I can just run there, and it gives us cosine x plus x sine x. I can now go on to this integral here, the integral of 1 divided by x minus 1 with respect to x. So I'll call that expression number 4 is equals to 1 divided by x minus 1. So I'll open parenthesis, then x minus 1. I can just run. So we have our expression number 4 is 1 divided by x minus 1. Then we go on and integrate that expression. So I'll call my output I4. We are integrating expression number 4 to get I4. So it will be int, open parenthesis, int E4. Then I can go on and run here. And it gives us log x minus 1. And you should recall that when you are in MATLAB, the log there is the natural logarithm. That's the natural logarithm of x minus 1. So what I'm typing here, I'm typing int E4. But if you want, you can even type, instead of E4, you can just write the expression there, int 1 divided by x minus 1. It gives the same solution. So I now go on to the next integral, this one, an indefinite integral here. Press the return key, then enter the code. So I'll call this expression number 5. So expression number 5 is equals to 5 multiplied by y squared, then multiplied by cosine, open parenthesis, of 4 multiplied by t. So it's 5 multiplied by y squared multiplied by cosine of 4t. I can press the return key here and just run. So it's 5y squared cosine of 4t. So now to integrate it, I'll call the output I5 is equals to, then int, open parenthesis. We are integrating expression number 5, so it's E5. But in this case now, we are integrating with respect to t when we are having variables y and t. So we need to specify that we are integrating with respect to t. So I put a comma t. If you don't specify that you are integrating with respect to t, what MATLAB does is it takes the default variable. In this case, when you are having y and t, the default variable is the variable which is closer to x. So the variable which is closer to x is the y. So if you don't specify t, it will integrate with respect to y. So don't forget to specify that you are integrating with respect to t here. So I can go on and run. And it gives us the solution there, 5y squared multiplied by sine of 4t divided by 4. I now go on to this integral now. We are now looking at a definite integral. We are integrating from 0 to pi. So I click here, press the return key, and then code. So now for the code for evaluating this integral, I'll first enter the expression. So my expression, I'll call it E6. E6 is equals to cosine, open parenthesis, x minus 8, and then times x squared. I can just run to see if I've entered the expression correctly. So it's cosine x minus 8 times x squared. I then go on and integrate that expression with respect to x, putting the limits 0 to pi. So I'll call my I6 is equals to, we are integrating, the expression that we are integrating is E6. So we are integrating E6, then comma, specify the lower limit to 0, then the upper limit is a pi, so we just put in pi. And then I go on and run here, and it gives us I6 is equals to minus 8 pi cubed divided by 3. So for the definite integrals, you just have to specify the upper and lower limits here.